Next we come to rotational symmetry. Now when an object rotates, we have to remember the shape and size do not change. So it will have symmetry if the shape and size does not change. So let us start with an equilateral triangle. This is ABC. Now a full rotation means that the angle that is covered is 360 degrees. So the angle by which a figure rotates is called the angle of rotation. So the angle of rotation is 360 means the figure has completed one full cycle. That means A has rotated and come back to its position. Now the rotation could be clockwise. This is clockwise, just like the minute hand of the clock moves or the hour hand moves, and it could be anti-clockwise, that is against the minute hand of the clock. So we have a clockwise rotation or an anti-clockwise rotation, that doesn't matter. Now what is important is that the point from which rotation takes place is called the center of rotation. So this is the center of rotation, and the angle by which it rotates is called the angle of rotation. So full rotation is 360. If it is rotated by a quarter, that is 360 divided by 4, that's going to be a 90-degree rotation, and if it is a half rotation, that's 360 by 2, that's 180 degrees. So you could have a full rotation, you could have half rotation, or you could have a quarter rotation depending on the figure. Now if you take specifically the example of an equilateral triangle, if I take this as the center of rotation and I join it to A, B and C, assuming this as the center O, then what happens is that if I want to find out these angles now, the total angle here is 360, we will take these angles as x. Now the sum of angles of this is going to be 360 degrees. So I can say 3x is 360, therefore x will be 360 upon 3, 120 degrees. So I can say each angle at the center AOB, BOC and COA is going to be 120 degrees. So if I want to rotate this figure, I have to rotate by 120 degrees. So let's see what happens when we rotate this figure. So here, if I am going to rotate by 120 degrees the first time, what happens is that this A now comes here. So this B gets transferred here. It's a clockwise rotation. So we are going to get B here, we are going to get A here, and we are going to get C here. So what happens is that the shape of the figure remains the same. It's an identical figure, but what has happened is the position of the alphabets, if you note, has shifted one place to the right because it's a clockwise rotation. So this is the first rotation. I can also rotate again. So what happens is that now the A position shifts here, C goes here and B comes here. So you will find that this is the second time when we rotate, the position A has transferred from here to here. Now if I rotate once more, we will get back the figure. So I can say there are three possibilities, or there is the order of rotation for an equilateral triangle is 3, because I can rotate it in 3 possible ways, and in all the 3 possibilities we find that the shape remains the same, they are identical. Only thing is that the position of the vertex keeps changing. Now if I am going to rotate it once more by 120 degrees, this position A will come back to its original position and we will get back the figure.